I got us leaving off at number 54, which these aren't in any kind of order, but I believe it was this 54. And just reviewing that concept. What's the area of a circle inscribed in a square? So here's the square. Yeah, I remember we did this one because I asked you what inscribed meant, and you knew. And we know the diagonal of the circle is 8. But to figure out the area of the circle, we need its radius. So we use the diagonal of the square to figure out what the side of the square is. That's relatively easy. In fact, it's 8 divided by root 2. And that becomes the diameter. So half of that, or 4 divided by root 2, is the radius. And this is kind of a good example of where you don't really need to worry about rationalizing either that or that, because the area of the circle is pi r squared. So this thing's going to get rationalized automatically when you plug it into the formula. So I would say don't ever worry about rationalizing it until you get to the final answer, because you might not have to.
Yeah.
57 is next. Right off the bat, I don't like the way 57 begins. What's wrong with the first 5 words?
Sphere.
Well, the area of a sphere, I mean, either they should say the surface area, or it doesn't really make any sense. A sphere is a 3-dimensional solid. 3-dimensional solids don't have areas. They have surface areas. So what they really mean is the surface area of a sphere. Okay? We'll call it that. Surface area. What does it mean when it says varies directly as the square of the radius? How can I write that?
Isn't it just
If I say y,
r squared?
if I say y varies directly with x, that's what it means.
Okay.
So if I say that the surface area of a sphere varies directly with the square of the radius, that's what I mean. Now, we happen to know that surface area is equal to 4 pi r squared. So in this particular sphere, k is 4 pi. But maybe that's why they stated it like that, is that we weren't supposed to use the formula that we know to be the surface area of a sphere. We don't need it. How do we do the rest of this problem? And they're going to stick with their area. They're not ever going to say surface area, because it's not fundamental to the problem. We don't need to know that that's surface area.
Wouldn't it just be...
What's the key to the problem?
Actually, just plugging it into the equation.
The key is to solve for k. Okay? In other words, the second sentence tells you that the area is 36 pi when the radius is 3. So that's going to allow us to solve for k. K becomes 36 pi over 9. That's what K is equal to. Well, we kind of knew that, but if we didn't know that, now we know the formula for surface area. Surface area is 4 pi r squared. And now it's no problem to figure out what the area is when the radius is 6. It's basically going to be, it's going to be 6 times this. Because when we square 3, we get 9, but when we square 6, we get 36, which is 4 times bigger than 9. So the surface area is going to be 4 times bigger also. So it's got to be E.
Yeah.
But whenever you have varies directly or varies inversely, it's always a problem where you're going to have to solve for K. But the key part of this is being able to really write the first line. There was a reason they didn't say the surface area is equal to 4 pi r squared, because they didn't want you to use that. They wanted you to have to solve for K.
Yeah.
Probably why their terminology was strange. Okay, we got more chord problems. Let's not do those. Let's go to the next page. ACT 3. Still very heavy in geometry. Not 100%, but that's fine. We don't want it to be 100% geometry, really. Let's draw our parallelogram. And we're going to draw it so that it is not a rhombus. When you're given a problem about a parallelogram, do not draw it like that, because that might produce something different or not as visually obvious as we draw it more elongated. Let's make sure that it is not a rhombus. It's just a parallelogram. They're saying the diagonals intersect at E.
One second. Let me go kick people off the internet because my internet is so crappy right now. Someone's like sucking all the internet up in my house. Let me go kick people off. 1 second.
I hate to do that, but if that's what you have to do.
No, I just have to get my sister off the internet.
Okay.
1 second. All right, hopefully that's better.
Okay.
Yeah, that's definitely better.
What do we know about BE and ED?
They're equal.
Yeah, and if you don't remember that from the rules of, parallelograms and rhombuses and trapezoids and all of that, remember that we're dealing with parallel lines. Okay? So that angle 1 has to be equal to this angle 1. And this angle 2 has to be equal to this angle 2. And this angle 3 is equal to that angle, so we're dealing with congruent triangles. And therefore, this is the same distance as that. And that's the same distance as that. Therefore, dB, the entire diagonal, is 4x plus 2, and dE has to be half the diagonal. So 4x plus 2, the entire diagonal would be equal to 2 times half of it. And now we just have an easy equation to solve. What do we get? We get 2x equals 6, x equals 3.
All right.
Let's look at this one. This is a kind of problem that you can expect to see on the ACT. This is an isosceles trapezoid.
Right.
Let's draw it because, first of all, we know the area of a trapezoid is the average base times the vertical height. Question is what is the vertical height here? We can tell the average base is 60. That one's 50. That one's 70. So the average base is 60. What if I drop a vertical? And that's 26. And what's this distance right there?
That's 10.
And that's all we need to solve for the vertical.
So the vertical is 24.
Wow, that is good. You really know that 5, 12, 13 triangle, don't you?
Yeah.
All right. And so we have the area then is equal to the average base, which is B1 plus B2 divided by 2 times 24.
1440.
Okay, good. Let's work vertically and then we'll go horizontally. There we go. Another trapezoid problem. They do like trapezoid problems on the ACT. BC is parallel to AD, so that makes it a trapezoid. If BC is 7, BE is 4, and AD is 12, what's the area?
So it would be would be 38.
19 divided by 2 times 12. 6 times 19.
No, you did that wrong. It's 80. So it's 12 plus 7 divided by 2.
Is 12 plus 7. That's 19 divided by 2. So there's your average base.
Yeah, times 4.
4. Okay. So I can do this. So it's 2 times 19, 38. Works much better since that answer is on there. In other words, is all we need. There's nothing even sophisticated about this question at all. You just need to know the area of a trapezoid. And they kind of throw you off here by drawing this little triangle here. which kind of makes you want to figure out, well, what is this distance AE, which you don't need. And in fact, I'm not even sure we can figure it out. Maybe we could, but it'd be a waste of time. It's kind of a misleading line that they drew there. But I guess they had to draw it to tell you what the height was. Given a square, rectangle, trapezoid, and a circle, if one of these figures is selected at random, what's the probability that the figure has 4 right angles?
Is it 1/2?
It's either a square or a rectangle, which is 2 out of the 4. Okay, I guess that's all we're going to find on ACT 3. Whoa, blew it up a little too much. If the perimeter of a square is 3x, then in terms of x, what is its area?
Wouldn't it?
What's the side length? In other words,
Is it 0.5?
use fractions.
Okay, 3/4 x.
Yeah. Well, now what's the area?
Is it just yeah. So
What is the answer? What's 3/4 x squared? In other words, we have to square that whole thing.
Oh, so 9/16
X squared. Right.
Yeah.
Okay. What the heck was open today that you had to go to work? I thought that everything was closed on the. When I'm watching the news this morning, I said to myself they'd be better off showing what was open because nothing was open. They had to list everything that was closed.
The ice rink was still open.
The ice rink was open. It probably stays open in all kinds of weather, huh? It's probably like
we ended up just closing it at 2 because no one was coming.
That makes sense. Yeah, yeah. You'd have.
But if people were going to show up, we were going to stay open. So.
Wow, that's on the top of that hill there too, isn't it? Off of Ward Road, that ice rink.
Yeah.
Yeah, that must have been fun looking in the middle of a blizzard.
Yeah,
top of a mountain like that.
Driving up Ward.
Yeah.
Driving up Ward was fun.
Oh, God. Oh, man. All right, let's see. And the figure below has side lengths of 6 and 8, which are shown on the picture. If x not shown is the midpoint of CD and y is the midpoint of AD, what is the perimeter? Okay, so hold on. So there's x, the midpoint of CD, and y, the midpoint of AD, or actually over here, and triangle XYD. So, gosh, And that's 8, and that's 6. What's the perimeter? Ah, much better question. I was going to say I'm not impressed with the area, because the area question is too easy.
Yeah.
And this has to be 4, and this has to be 3. Still too easy, huh?
Yeah, because then it's just 5 is the other side.
Which means 12 is the perimeter. I guess even if it was not a 3-4-5 triangle, it would still be easy. In other words, let's say they made this 5 or 7, something like that. Well, then we still just have to use the Pythagorean theorem to solve for that. There's no trig or no angles that you have to figure out or anything. You just have to solve for that hypotenuse. And they make it easy, which they tend to do. I would say of the triangles they give you, 90% of them are going to be 3-4-5 or 5-12-13. One of those two. So recognizing them really does save you a lot of time and not having to do the Pythagorean theorem. In rhombus, what's the definition of a rhombus?
Isn't it 4 equal sides but not equal angles?
That's it. Just 4 equal sides. You're right. The angles don't have to be equal, and in the way I drew it, they're not. Although the opposite angles are equal, always, and the adjacent angles are supplementary, always. But the main thing you should remember when you think about a rhombus is it's just 4 equal sides. So a square is a rhombus. And A, B, C, D. So if AB is 4x, how am I going to solve this?
Can't you just solve one of them for x, then just plug it in the other one?
Well, direct me. Tell me what you mean.
So, like, for the BC one.
I cannot solve that for x. There's 2 unknowns there. There's BC and there's x.
Oh.
So the only way you can solve for x is if it's the only variable, if you only have one equation. However, what do I know about a rhombus?
They're equal.
AB is equal to BC.
Yeah.
So what equation can I write?
Is then just 4x minus 2 equals 3x plus 3.
Yeah. And that is x equal 5. Let's see here. You're doing pretty good with this geometry stuff. Given that it's been, what, 2 years since you finished geometry? Yeah. No, that's why this person exclusively made a practice test full of geometry problems. Is because that's a very common problem for people taking the ACT, like yourself, who are on a little faster track, and it's been more years for you since you took geometry than it is for a normal student who's not on the fast track. So people that are a little bit more advanced actually suffer a little bit of a disadvantage on the ACT because they're an extra year removed from geometry. Let's see here. What's x going to be? How are we going to get it? Just tell me how we're going to get it.
You can do it 2 ways. You can add all 3 of those angles up and then subtract that by 360.
Okay, that's one way. That's the only way I know to do it. What's the other way?
Actually, yeah, that is the only way you can do it, because they're not supplementary.
Right. This is not any kind of a trapezoid or a parallelogram or anything. So we don't know anything about the angles other than that the four angles have to add to 360. Okay, similar question as before, only they mixed it up a little bit. I'm not going to say anything. They want the perimeter. How do we do the other problem? What do we solve for first?
K.
No, we didn't really. In the previous problem we solved for side length.
Oh.
Right? In other words, they gave us the perimeter and we divided that by 4 to get the length of each side. It's key that they're talking about a square here. If it was a rectangle, we wouldn't be able to do it. So let's use the same exact logic. What's the side length equal to?
Isn't it just the square root of K?
Okay. And what's the perimeter equal to? If that's square root of K.
Would be 4K?
4 square roots of K.
Yeah.
The perimeter,
yeah.
Well, there's a 4K answer on there. So it's important that you keep the square root in there. In other words, the perimeter is one side times 4. Well, if side length is square root of K, then the perimeter is 4 square roots of K. Okay. That's essentially all of these special geometry questions I have. However, I'm not out of tests. We did all of the McGraw-Hill, and we did those for ACT 1 through 4. Yeah, I got another couple of practice tests here, I think. Yeah, certainly have some questions on it. Not so heavily geometry, but still very interesting. They always have a problem like this on the test, it seems, where you have to figure out times. We're going from 5:10 to 7:35. And probably the safest way to do these, in other words, you could do it as a subtraction problem probably, but it's since they put the times so close together, in other words, had they given you 1 o'clock and 11 o'clock, might have been harder to do it the manual counting way. When's the next chime going to take place? After 5.
Is it 5?
And then 5:30, and then 5:45. And then at 6 o'clock, so we get 1 chime there, 1 chime there, 1 chime there. How many at 6?
6.
Okay. And then at 6:15, 6:30, 6:45, 1 each. How many at 7?
7.
And then another one at 7:15 and 7:30. Add those numbers up and you have the answer. There's that 1921.
Yep.
You see why this would have been a little harder if they'd have gone from 1 o'clock to 11:35. Then we might have needed to come up with a better way of doing it. I'm still not sure what that better way would have been when it chimes the same amount as the clock is. I can't imagine we're going to be able to come up with a quick and easy formula for that. So, but certainly when you're taking the test, you would never want to spend the time to see if you could come up with the formula. Not when you just have to go from 5:10 to 7:35. You can be very precise by doing it that way, and there's no question about it or anything else. I suppose another way, almost, is you can rule out 3 immediately. You can actually rule out 15 immediately, and you can rule out 45 immediately. So even if you had to guess, you'd be guessing between 18 and 21, which isn't bad, 50-50.
Yeah.
But there's no need to guess on a question like that. Which of the following could not be the sides of an isosceles triangle?
B.
Did you say B as in boy?
Yeah.
Yep. It requires 2 sides that are the same. And that's the only one that does not have 2 sides the same. That actually technically is an isosceles triangle. It's also an equilateral triangle. But the definition of an isosceles triangle is 2 sides are the same. It is not 2 sides are the same and different from the third side. So an equilateral triangle is technically an isosceles triangle in the same way that a square is a rhombus. Not all rhombuses are squares, but all squares are rhombuses. Which of those is not equivalent to 2 3/8?
I think H.
Correct. H is 6/8. In other words, it just would multiply the numerator. Ooh, good logic question. These are hard sometimes. You have to kind of think about it. A B is always an A C is always a B, and a D is always an A. Well, let's just go through them one by one. Is that necessarily true?
No.
About this one?
No. No. Yeah.
Yes. In other words, we didn't even need.
I think so.
We didn't need this third statement. The first 2 statements tell you that if a B is always an A and a C is always a B, then a C is always an A. And all I need is those 2 statements there. I don't need this one. They threw that in there just to kind of confuse you a little bit. I think maybe this is okay. Okay, these are good. I mean, tough, I think. Well, this isn't that tough.
Yeah.
There is one general formula that you definitely want to remember for taking this. And it's surprising to me how many students don't remember this formula. What's the formula that relates distance, rate, and time?
Isn't distance is equal to rate over time?
No. Here's a way to remember it. Dirt. So what is it? If that's the way to remember it, what is it? Distance equals rate times time.
Yeah.
And that's the only one you want to remember. In other words, it's also true that rate equals distance divided by time, or that time equals distance divided by rate. Problem is if you try to remember all variations of it, it makes it much tougher to remember the primary one. So I specifically never memorize the variations of it. And that's why dirt never fails me, because all I got to do is replace that I with the equal sign. Okay, so if dirt applies, let's see if we can figure out some times here, because they give us the rate that she runs the first half of the race. So how long did it take her to run the first half of the race?
It would be...
Tell me what to fill in here.
It would be 13.1 is equal to 8 t.
T, right. So the first half equals 13.1 divided by 8. Let's just leave it like that for the moment. The second half.
It would be 13.1 and then 6t.
Divided by 6, right?
Yeah.
So the whole thing is going to take her 13.1 divided by 6 plus 13.1 divided by 8. Can we figure out the answer from that? Not without a calculator, probably.
Yeah.
Sometimes you can. In other words, it looks to be, to me, if I had to guess, I'd say 4.12. It's certainly not that, because we can tell that this number is greater than 2 and this number is greater than 1. Now, given that they give you a calculator, there's no need to really spend a lot of time figuring out how to get this answer without a calculator. But it's a habit I can't break myself of. You know what I mean? I would prefer if they gave you these tests without a calculator, because then you would have to use some of these more esoteric techniques for coming up with an answer. But they'd have to give you more distance between these numbers also.
Yeah. And more time.
Well, yeah, they would. But if they put more distance between these answers, it'd be pretty easy to approximate that. In other words, this number is what? That's 6 goes into 12. That's about 2.2. And that is 1.6. So the answer's got to be 3.82.
Yeah.
And so I actually was able to do it without a calculator, but you certainly don't want to spend time trying to do it without a calculator if it takes extra time.
Yeah.
I only could wish that your problems will be as easy as these practice tests. This practice test. I think this is a bit of an easier one than normal. So what's the answer?
would it be?
Can it
Is
have,
it E?
can it have 3 zeros? No, because it's
No.
compounded yearly. In other words, at the end of the first year, she's going to make 22,000. But then at the second year, this is going to go up by 10%. Well, 10% of this is not going to give you a nice round number with 3 zeros on it. I got to add 2,200 to that number, which gives me 24,200. That's her second year salary. And you pretty much can figure that out just by the fact that they've kind of told you in the middle part of this question that it's compounding. In other words, she doesn't get 10% increase over 20,000 a year. She gets 10% over her salary for that year. And so instantly you can look at this and know that E has to be the answer. And that might be a case where it would be useful to use that trick, although it's not that hard to do it manually. In other words, it's easy enough to figure out what her salary is at the end of year 1 and at the end of year 2 by just multiplying it by 1.1. Notice that technique, let me just, can you still hear me, Mitch?
Yeah.
Okay.
Yeah.
I got flashed a message saying audio having difficulties. Notice that when you increase something by 10%, there's 2 ways to do it. I can multiply that by 0.1 and add it to the original. But the faster way to do it is to multiply the original by 1.1. Same thing, only you get it in one immediate. Especially since you're using a calculator, it's definitely easier to multiply something by 1.1 than it is to multiply it by 0.1 and then add it to the original. So if something decreased by 30%, how would I, if my salary went down by 30%, starting from 20,000, how would I figure out what it went to?
Couldn't you just multiply it by 0.7?
Yes, that's exactly what I was getting at. That's the fastest way to do it. You could also multiply it by 0.3, take your answer and subtract it from 20,000. But using that for increases and decreases is faster, regardless of whether it goes up or down. Okay, can you read 14? A little hard to read.
Wouldn't it just be Pythagorean theorem? So
hold on. Pythagorean theorem only applies to right triangles. Only. So let's draw this triangle and let's make sure we do not draw it as a right triangle. Okay, there's A and B. And there's C. And C is the length of the longest side. So that's definitely not true. How about that?
No.
Actually, that is the answer. And it's based on the following, which you also have to remember. And let me write it out, because once you write it out, it matters. Any side of a triangle has to be less than the sum of the other two. And what's the rest of that statement? In other words, this is the only part you have to memorize. The second part is the opposite. And what?
Wait, can you repeat that? It didn't all come through.
Yeah. Any side of a triangle has to be less than the sum of the other two sides. Always. Why? Because the shortest distance between 2 points is a straight line. So how can A plus B not be greater than C? Has to be. In other words, according to this, C has to be less than A plus B. And the rest of the statement is, and what? The rest of it is the opposite, meaning greater than the difference of the other two sides.
Right.
So this is what you have to memorize, but like all memorizing stuff, you really only have to remember the first half and then remember that the second half is just the opposite of the first. Instead of less than the sum, it's greater than the difference. And it's all based on the shortest distance between 2 points is a straight line. Therefore, C has to be less than A plus B because I get A plus B by going in a crooked line. Okay? But
yeah,
this is the key thing to remember right there. And that's not a real common thing taught in geometry. In fact, you can probably take a whole semester of geometry and never be taught this. It's just kind of something that, I don't know, it's always puzzled me. I've never had a geometry student give me a problem that related to this. Tell me which of these triangles is possible. Or which is impossible? How about the top one?
Yeah, that's possible.
Pass that test right there?
Yeah.
Is 5 less than 2 plus 2?
Oh, no.
So this one is not possible. And remember, it's any side. For these to be possible triangles, every side has to pass the test. Okay? So if we examine this, 6 has to be less than 7 plus 8, which it is. It also has to be greater than 8 minus 7, which it is. And then 7 has to be less than 6 plus 8, which it is. And 7 has to be greater than 8 minus 6, which it is. And it has to pass the test for that side also. 8 has to be less than 6 plus 7, has to be greater than 7 minus 6. So the middle one is possible, and that passes the test all the way around also. And almost certainly you will get a question like this, and it'll be in this form. It'll give you 5 choices, and it'll say which one cannot be a triangle. And you'll have to apply this test everywhere until you find one that fails.
All right.
And they made this just a little bit tougher by putting the A plus B has to be greater than C instead of saying C has to be less than A plus B. And they really should have put parentheses around this, but I guess there's no other way to interpret that when you have a greater than sign. You know what I'm saying? It'd make a little bit more sense if we had parentheses around the A and the B there.
Yeah.
What's the y coordinate of the midpoint of that line? Now, we could go to the trouble, but it would be a lot of wasted trouble of doing this.
Yeah.
What's the midpoint of that line? What's the y coordinate of the midpoint?
Isn't it just 8?
Uh-huh. In other words, we didn't need to draw it or know anything. When you're talking midpoints, the what's the x coordinate of the midpoint? How would I find that x coordinate right there?
6 point.
Yeah. In other words, I would add that to that and divide by 2. So you get minus 13 divided by 2, which is minus 6.5.
Yeah, that's what I was thinking.
Would have been a little better question if they'd have said, what's the x coordinate of it? Then maybe I might have had to draw the picture, but not really. Always remember, midpoints are really easy. It's just the 2 coordinates added together divided by 2. And that handles all pluses and minuses. All right, done with practice test 2. Now, I don't know whether we did these, to be honest. Gosh, not sure I can tell. In other words, McGraw-Hill, I have 3 practice tests. I know we did all of those. And I have 2 more practice tests. Do you think we've done 5 practice tests? I don't think so. I think we started on the McGraw-Hill.
Yeah, I think so too.
We don't have that much more time today, but for future reference, because you take this test relatively soon, I would imagine that we're probably going to want to put in another session or 2 on ACT practice. Even if we did these, we did them like a year ago. So let's start with 2. And they start out so easy. Let's start. The problem is if I start in the middle, I won't know where we left off. Let's go ahead and start at the beginning. I know what we'll do. Yeah. All right, let's go ahead and do 1. Do you have a calculator in front of you?
Not a full-on calculator. I have my phone, but my other one's up in my room.
The reason I ask is that this is not going to be that easy to do with a calculator.
Yeah.
Notice what's going to happen is that it may give you an answer, but it's going to be a decimal answer. And then we're going to have to figure out which one of these fractions is that decimal. So this actually might be easier to do without a calculator. What is 3 3/8 decimal wise?
It's 30, isn't 3?
Hold on. I didn't mean to do that. I didn't mean to convert it to decimal. Let's find a common denominator. So all we got to do is subtract 1/3 from 3/8.
Yeah.
What is 3/8 minus 1/3? What's my common denominator?
24.
What's my numerator on the left?
Its left is 9.
My numerator on the right?
8.
So that is what?
1/24.
Okay, so what's the answer? Ooh, hold on.
What?
Oh, it's a plus problem.
Okay, Mike. Right, there's none of those.
I misread the problem, but that's okay. I mean, that's 17/24. So what's the answer now?
E.
Yeah. But this does illustrate a problem for people that can only use their calculator. I'd venture to say that there'd be a lot of people who would be hard pressed to answer that with a calculator. It'd be a lot more work than finding a common denominator and just adding the two fractions the way we did it. You know, once you read the problem properly, at least. Because you could put that into a calculator, 3 3/8, and add it to 1 1/3, and come up with 4 point something. But unless your calculator allows you to switch between fractions and decimal, don't they give you a special calculator when you take the ACT? You don't get to use your calculator, is that correct?
No, we get to use our calculator. They just put in a press to test.
They put it in test mode?
Yeah, and that doesn't allow you to switch.
Okay, so that does take away the key that allows you to turn a fraction into a decimal. So this could be a bit of a problem. In other words, you'd come up with a decimal if you used a calculator, and then you would just have to put each of these into your calculator and see what decimal that is. Actually, the only thing you'd have to put in is the fractional part. Right?
Yeah.
Okay. I still think it's easier to find a common denominator and do it. Because doing it the other way, you're going to have to check each of these fractions. Well, maybe not each of them, but certainly anything that's close. I bet you'd have to check between 4/11 and 17/24 on whatever answer you got. Maybe not. I don't know.
No, you probably only...
Your decimal's going to be greater than 0.5, isn't it? Yeah.
Yeah.
As long as the decimal's greater than 0.5, you're home free. It's that.
Yeah.
All right. So what's this one?
So
always start piece by piece. In other words, you may not have to figure out the complete answer. Start with the numbers. And then let me tell you what I mean. What's the numerical part of the answer?
5 times 6 times 2.
Okay. What's the x part of the answer?
There's 4 x's.
X to the 4th.
Yeah.
That's all you need to do. You don't need to figure out the y part. Why? Because there's only 3 answers that have 60, and there's only one of them that has an x to the 4th to go with it. Okay.
All right.
It doesn't save you a lot of time on a problem like this, but I've noticed that a lot on the ACTs, is that a lot of times you get your answer just by halfway through the problem. And any time you would spend figuring out what the y part is wasted time. You don't need to figure out that it's y to the 8th. All right, that's a good place to stop. I'll make a note that we got through test 2, question 2. All right, Mitch, have a good rest of your week, and I will talk to you next Wednesday.
All right.
All right, bye-bye.